Good afternoon, everybody. My name is Kalai. I'm a senior staff network engineer at PayPal. Today, we're going to talk about building bridges across public cloud. It's the PayPal way how we solve the business challenge we ran into using HAProxy. I'm partnering together with Sid, and Sid is going to give us the bit background about the PayPal's global infrastructure and the challenges we face today. And then I'll jump into a bit about the solution, and we'll talk about the results and the closing thoughts further. Over to you, Sid. Thank you.
Thanks, Kalai. Yeah, good afternoon, everyone. My name is Sid. I prepared a brief introduction, but I don't want to do it after Dylan introduced us. So let's go to the next slide. So this is the agenda that we are going to talk through. We are going to talk about PayPal's global footprint, the challenges that we ran into and the solution we came up with, some results, and then the closing thoughts. So before we go into the technical details, I want to give you a quick overview of who we are and the scale we operate at. So PayPal was founded in 1999. We started as a simple online payment platform, but then we evolved into a most trusted financial institution in the world. So we have a number of business units. So you might know all these already. So as you can see, Venmo, it's a social peer-to-peer payment platform. Xoom provides international remittances. Zettle, it provides the POS solution and for small businesses and in-store payment options. And Honey provides the digital rewards and shopping tools. Braintree, it provides the payment processing for businesses. Hyperwallet provides a mass payout option for businesses. And finally, PayPal Credit, it provides financial options for consumers. So we currently have 436 million active accounts or active users on the platform. We offer in 200 plus countries. We processed $1.6 trillion of total payments last year. So to support all this, we need a global presence and global scalable infrastructure to serve our customers. So with that, let's move on to the PayPal's footprint. So yeah, as you can see, PayPal is a hybrid multi-cloud infrastructure. We have a three-tier architecture. We have global edge. So we distributed globally using multiple CDN providers. This helps us to terminate the customer connections close to their proximity. It reduces latency, provides better performance for the customers. We also have security controls at the edge. This helps us to stop the bad traffic before entering our core network. Then we have a hybrid backbone strategy. The second one is the backbone. So PayPal, we own our private backbone. We provide connectivity between our data centers, the DCI connectivity, and then we have POPs across the globe. So our backbone provides connectivity between our POPs. Also, our backbone provides on-ramp to the public cloud providers. So we have GCP interconnects, AWS direct connects, and then express route, all connectivity to the cloud. We also leverage public cloud backbone. So if the customer, to enable the multi-region communication between the cloud regions, we use the cloud provider backbone. We don't want to bring the traffic back to on-prem or use our backbone to have the latency benefits. And finally, compute and services. As you can see, PayPal has a large presence on-prem. We have presence in GCP, Azure, and AWS. Our business units are spread across all three cloud providers. So having this hybrid multi-cloud infrastructure, it provides us a global reach, provides us resiliency, but at the same time, it introduces a layer of complexity. So we have to deal with multiple cloud providers. We have to deal with how to connect all these business units together. So with that, let's move on to some of the challenges we ran into. So these are some of the challenges we face today. So one of the core challenges that PayPal faces is because of the acquisitions. So before the acquisition, all these entities, they are independent platforms. They don't need to talk to each other before, but after the acquisition, as we started to integrate the services, as we started to make them to talk to each other, uh, all the organizations use RFC 1918 space. They all use 10/8. So it's an issue to make them talk each other with the overlapping IP space. No easy way to expose the services between the entities without going over the internet. Degraded application performance. So with business units spread across multiple cloud providers, let's say we have payments API in AWS, wanted to talk to risk API in GCP, then wanted to talk to a compliance API in Azure. It's very hard from the latency perspective to achieve all that. And finally, also the limited visibility into the flows. If something happens, there is no single pane of glass to look at the traffic flow end to end. It's hard to detect what went wrong since you don't have the end-to-end visibility of the flow. And finally, the standards across public cloud providers. So there is no, each deployment, everyone enables things differently. AWS has private link, GCP has PSC, they are different. So it's hard to have that uniform deployment across the providers. So given the complexity and the scale of hybrid multi-cloud environment, we actually wanted to have a solution, a reusable solution that can abstract the complexity of the cloud providers. That's where Meridian comes in. It's a hybrid multi-cloud connectivity fabric. It's a project name within our company. So it's a hybrid multi-cloud connectivity fabric that provides a simple and unified solution for the business units to talk between themselves. So we started Meridian using public cloud providers' native services like AWS, Private Link, and GCP PSC. But soon we realized with all the, we are spread across multiple cloud providers, our business units are across cloud providers, we are on-prem. So we soon hit a roadblock and figuring out a uniform solution across the cloud providers. So that's where HAProxy comes in. So we leveraged HAProxy as the core component of our solution. They provided a unified multi-tenant solution without reinventing an access pattern for each cloud provider. So yeah, this is the high-level Meridian architecture. As you can see, we have 2 layers in Meridian. We call it inner Meridian layer and the outer Meridian layer. So inner Meridian layer is the one that provides connectivity between the business units. So if one business unit wants to talk to other one, it uses the inner Meridian layer. If business unit wants to talk to any of the cloud services like AWS, LLM or GCP LLMs, it uses the inner Meridian. The outer Meridian is to provide connectivity for the business units and PayPal to talk to the external companies, or the SaaS providers or the partners. And as I said before, HAProxy provides us that multi-tenant solution across the cloud providers. Yeah. So next, we'll go into the solution. Kala will take you through the solution.
Thank you, sir, for giving us the quick background on the complexities and the solution. So let's jump into one of the solution we built. As you could see, this fits into the inner Meridian architecture. We call it as Meridian Edge. If you closely note out this architecture, you can see all these business units are distributed across the cloud, and all these BUs have the same 10/8 IP space. And they are distributed across different regions. The boxes we call as Meridian Edges are the HAProxy clusters. We have multiple HAProxy clusters that are distributed for each of the cloud providers, for each business units, for high availability and traffic management. And then we have the GNS Meridian orchestrator, which is using Fusion as a core component, which helps to manage all these clusters to onboard new front ends or onboard new services, updating map files, all those operational and observability is taken care by Fusion. And all these different Meridian edges across these clouds, as you could see, they are connected using the Meridian Edge Services Fabric, which leverages PayPal's global backbone as well as the public cloud backbone together to have this low latency path reachability. So to help us to understand, right, how the traffic flows and how the system works, we can jump into a specific flow. Next, we'll see how the packet flows from one business unit to another. So let's take an example. So in this example, right, we have a PayPal core system we call it as App1 on their side. It's going to reach an application in AWS in business unit 2, which is App2. So what we wanted is, we want a way to reach the application 2. Now, there are multiple ways to reach application 2. How does the Meridian Fabric identify that this traffic is destined to business unit 2 and this application, and how does it do the routing? So the idea we took here is, we will use a domain name and an URI path combination. Instead of the subdomain, we choose the domain name plus an URL path combination to distinguish and figure out what Meridian edge the traffic should be destined to. So as I said, in this example, we can take that the endpoint name could be example.paypal.com/bu2/app2. So what happens is, the application 1 will be configured to reach this particular endpoint with a specific URL of bu2/app2. So the application 1 performs a DNS resolution. So here what we do is, we use our GTM or the cloud provider's native DNS solution to give us the low latency closest path answer. So on-prem we use the GTM and we figure out the closest Meridian edge, and then the packet goes to the Meridian edge. As you could see, the packet goes to Meridian edge 3, and when the packet goes here, one thing we noted is, the source IP is going to be the RFC 1918.10.x IP, and the destination is going to be a Meridian range. And the interesting part, which I missed to mention, is this Meridian Edge Services Fabric. If you all notice, right, they all have an overlapping IP. How they can talk to each other? This Edge Services Fabric is built using RFC 5785 range, which is 198.18/15 range. We built this whole fabric with this non-overlapping range, so that all these business units can talk to each other without we carve out a unique public IP space or anything. So that acts as a non-overlapping IP fabric across the business units. So when the traffic hits the edge 3, it's going to be a 198.18 space, and the Meridian edge 3 performs an SSL termination. After doing the SSL termination, it has to make a decision which Meridian Edge Services Fabric I should route to, whether it's Azure or GCP, whatever it is. So in our particular example, it's going to go to BU2, because the URI path in the map file says that I have to go to BU2/app2. So the Meridian Edge 3 has a map file config that does this routing lookup. It figures out it has to go to app2. So the traffic traverses through the PayPal Meridian Edge Services Fabric, which is our underlay is the PayPal global backbone. It reaches the AWS Meridian Edge. Now, once it reaches the AWS BU2 Meridian Edge, it accepts the packet, and then it has to rewrite the host header, and then obviously it has to strip the URI path. So the idea here is, we want to have the Meridian Edge Services Fabric as seamless as possible to the customer. We don't want them to on their application to understand all these additional components that are introduced in the path. So we strip the URI path information, and then we route the request to the application 2. Now, as we route this request, the BU2 Meridian Edge does an SNAT, where it translates the traffic from the Meridian range to the application's range in 10.x. So if you look at this whole architecture, right, what do we get? Like, what is the advantage we achieved by introducing this extra layer of NAT? Other thing is, right, in other words, the whole problem can be solved by just introducing a specific source NAT on each side, right? Now, what do we get by introducing HAProxy in this mix? So the biggest advantage we got is a performance improvement. As you could see, these systems are distributed across different regions. With introducing HAProxy closer to each of the clients, we do a closer SSL termination. And then the second one is these Meridian Edge Fabric, they all have a persistent HTTP2 connections enabled, which means that we don't have to every time, establish a TCP and SSL handshake. Because they're all, persistent connections, we were able to quickly pass the package to the next Meridian edge. That's the biggest, advantage we get this architecture. And the other thing is the observability is a big piece. Like Sid mentioned, earlier we had a challenge where when we go through internet or any providers, right, often we run into an issue, hey, I had an application timeout. Tell us, hey, it's a network. So tell us where is the issue. So when there is no clear footprint, we know that the packet left our infrastructure, but it's not reached on the other side. So with this architecture, we were able to get the logs on each of the layers. So as you could see, when the packet traverses the first layer of the Meridian HAProxy, we take a log, and then we have a second layer HAProxy, and we tie them together using a specific correlation ID using Fusion. Now, Fusion is our single plane of glass where we can take a look into the logs and see that, okay, this is the time that it took for the application to process, and we have this RTT, and okay, this is the application that is the response, higher, it's not a network. So that gives us a better ability. And another big flexibility we got with this architecture is we have multiple Meridian edges, so we can seamlessly swing the traffic to different Meridian edges and do a maintenance for the teams. That's idea about the Meridian edge. And now this covers the inner Meridian, right? So let's move on to the next level of architecture, which is an example of our outer Meridian service offering. So this is kind of very similar to the previous architecture, but a kind of different view of the system. So we call this as Meridian Gateway because, as I mentioned, this falls into the outer Meridian where we want to have a central control point when we want to expose to all these different native services. Like we have common use cases where we have a business unit in AWS that wants to talk to GCP. There is no way to privately send the traffic. Most of the time, you have to either go through internet or PNIs with those providers. Those systems are not as secure as we have our InfoSec mandate. And also, sometimes you also wanted to have some kind of control point where if we want to have any kind of observability or we want to introduce any new services like DLP or WAF, those things we need to have a central inspection point. So the idea here is we will build something called Meridian Gateway, which is again an HAProxy system that will be distributed closer to the client. And this HAProxy will be used to terminate all our connections from the business units. And then we do all the required security inspection controls there. And then we route the traffic to the specific provider. It could be AWS or GCP or a SaaS partner. We do that. And one major use case that we recently solved here is obviously with AA, right? Everybody wants to connect to AA systems. So we have a lot of business units have interest to explore the AA systems. So we wanted to connect an AWS system to a GCP Gemini model. So let's just understand the flow. It'll help us to go through the various actions that happens here. So we have a system in AWS that wants to talk to GCP LLM model. So what happens is the packet from AWS goes to the Meridian Gateway. We again assign a specific subdomain for this. It could be an GCP LLM.example.paypal.com. The traffic gets terminated at the closest Meridian edge or Meridian Gateway in this case, where we have a mapping that says if I get a request in the map file, when I get a request for this particular Meridian edge, I wanted to route the traffic to GCP because the subdomain is gcp_llm.example.com. So it's not just going to do the map file lookup and forward, right? As I mentioned, some of the challenges we have is depending upon the GPU availability, different cloud providers, example GCP, right? In US Central, they have a different GPU flavors, and in US West, they could have different. So we also want to do a traffic management. Our teams, the AA team, they might have a requirement to route certain traffic to certain region, and then we have to make that particular traffic management decision as we get from the request from the clients, and then we figure out that particular region and route the request to them. And another part is natting. Natting is the basic feature here because we have all these business units that have these overlapping IP ranges. So we want to make them unique. So we do an NAT to the Meridian range I mentioned, and then we do rate limiting. We don't want any of the business units to, just consume all the services. So we apply rate limiting based on the business, decisions that we receive from the teams, and we route the request to the specific, GCP LLM model. That's a use case about, the Meridian gateway, which is our outer Meridian, system. With that, right, we deploy the solution. Like Sid mentioned, we went through multiple evolutions of the solution. We went with, the cloud native, and then we tried the HAProxy. And here are the results, right? With the HAProxy, I just wanted to call out what things we achieved by applying this architecture. So one greatest advantage we saw is we got a 24% latency reduction in the application calls compared to the public CDN path. So as I mentioned, before Meridian architecture, when these business units want to talk to each other, we have to expose a risk API or payment API to, through the particular CDN provider where the business unit is hosted, and the PayPal or other system they want to connect to them, they go through this public CDN path. So we onboarded the same application into our Meridian Edge Services fabric, and we performed a benchmark testing. And we were able to get a 24% latency improvement. But that's not, it stops. The biggest value we had is, as soon as we pulled off those applications, just it was exposed because we want to, let them consumed for the other business units. There is no real reason to put them in the, public-facing property, right? So our security has predominantly increased because the Meridian Edge Service Fabric is completely a private path. So we have all these applications that can, be securely accessed. The attack surface is, completely reduced, and the performance gain is also super good. That's one of the benefits we got as a result of this. And another great thing we observed is because of this whole Meridian Edge Services architecture, whenever we want to expose a service, right, in the traditional way, every time we open a service, we have to open a firewall ticket, from A to B, again, C to B. So it's a difficult task, right? We have to expose the same application to multiple teams. So with this Meridian architecture, once a service gets onboarded into Meridian, we onboard only once. And we have a service directory where the other business units can come and say, oh, the service is already onboarded. I just want to connect to them, and they can connect to it. So that's a big plus for the, our system, where all the applications team can easily develop their application on their current infrastructure, and they can expose it or onboard it into Meridian, and we can easily share it to other business units. So as I previously mentioned, right, another great advantage we got with the Fusion control plane is we have all these logs can be, looked at as a single plane of class. Whenever we get a request in, we get to see it at different points of time. Either, at region 1, what happened to the request? What happened to the request at region 2? What is the network round trip time? And what is the total time took for the, HAProxy to process application response time? This gives us a very good visibility and troubleshooting capabilities. So all our teams are super happy because we often get into this situation where app teams, blame on network. A network team don't have a real thing to show that it's not a network. So with this Fusion, it was really amazing that we can just take the correlation ID, which is a unique ID generated by our Meridian fabric, just put it in Fusion, you get the log, and you have the nice visibility on what happened to your traffic. And last but not least, another thing, this is not actually part of the design, but we realized after we designed it, we solved this problem also, which is the efficiency, right? At PayPal level, we run like 3,500 applications. So all these applications, they have their own, way of modernizing the system. So sometimes it's pretty challenging. We have an application which could have still running in HTTP 1.1, and a business unit want to consume that API or that application. The team is, not having cycles to upgrade their systems, or they have a different priority. So at the same time, that application needs to be exposed to the, our business unit. So if we expose it with the traditional way, as we know with the HTTP 1, we are going to have a lot of performance hit, especially at PayPal scale. We have applications spread across different region. It's a difficult one. So what we did is with Meridian, HAProxy has this ability to translate HTTP 1 to HTTP 2, which is an added advantage we got, through which we are able to build a better efficiency. And as a whole, right, this solution helped us to accelerate the overall PayPal convergence strategy, As you could see, we have different brands, and we are trying to bring all the brands together to give a cohesive experience for our customers. And this Meridian Edge Services Fabric idea that we built using HAProxy really accelerated our convergence across the business units. With that, I'll hand it off to Sid for the closing thoughts.
Yeah.
Thank you.
Yeah, thank you, Kalai. Yeah, I would like to take this opportunity to thank everybody in the HAProxy team, Jacob and everyone. Thanks for partnering with us. For the solution. So closing thoughts, right? As we have seen, building that private connectivity between the business units is especially hard when there is a IP overlap. So we partnered with HAProxy, and they provided, it helped us to provide a consistent connectivity across the cloud providers. So the second one is the IP range that we use. So like Kalai mentioned, we used RFC 5735. So we looked at other IP ranges. For example, we looked at the CG NAT space, 164/19. But many of our business units are already using that for the GKE or EKS or AKS. Basically, they are using it for the pod range. So we went with the 5735, which is the 198/18/15. And finally, what's next? So we are working on the self-service. So we currently don't have self-service. So any onboarding has to go through the manual process. We have to onboard it. So we are looking at that self-service automation and also partnering with HAProxy to provide the service discovery option. With that, thanks everyone.